Hi everyone, in this video I'm going to solve A-Levels Pure Mathematics Paper 2 in a session February-March 2021 Paper 2-2. So let's start with the first question. Question number 1 part A. Sketch on the same diagram the graph of y equals to absolute of 3x minus 5 and y equals to x plus 2. Right, so first let me take the first function, which is y equals to absolute of 3x minus 5, right? So let us consider it as y equals to 3x minus 5, right? Let me find the x-intercept. For x-intercept, we have to put the variable y equals to 0. So we can say 3x minus 5 equals to 0. 3x would be equals to 5 and x is equals to 5 out of 3. Okay, and what is 5 by 3? Let me check in decimals. This is 1.67. This is 1.67. Now let me find the y-intercept. You have to put x equals to 0. So y would be equals to negative of 5 and x equals to 0, right? Okay. Now for the second function, we can say y equals to x plus 2, right? So y equals to x plus 2. So here we can say that y-intercept is y equals to 2 and x-intercept, or we can use the slope form as well. X-intercept when y equals to 0, x equals to negative 2. Right, now let me sketch the graph of these two functions on the same diagram. Let me draw the grid first. Okay, now let me select the scale in terms of centimeters. 1, 2, 3, 4, 5, 6, 7. Okay. For x, we can say 1, 2, 3, 4, 5, 6, 7, and minus 1, minus 2, minus 3, minus 4, minus 5, and minus 6, right? Okay, so let me draw the sketch of this function y equals to x plus 2. The y-intercept is 2 and the x-intercept is negative 2. Right, now let me connect them with a straight line. Right, now the graph of the absolute value function, it should be in the upward in the first and second quadrant when y is positive. So the x-intercept we got is 1.67. Let's say this point, and y-intercept is negative 5. So we have to do the absolute. So here we have to do the absolute of negative 5, which is y equals to 5, right? So y equals to 5 is 1, 2, 3, 4, 5. Y is 5, this point. Okay, let me connect the 2 points. Okay, so now let me consider some x value to find the other portion, the reflection basically. So if I can say when x would be equals to, this is x is 1.67, let's say x equals to 4. What is the y value, right? At x equals to 4, y equals to absolute of 3 times 4 is 12 minus 5, which is 7, and absolute of 7 is just 7, right? So when x is 4, 1, 2, 3, 4, this is 4, y value is 7. So let me connect this with 7. This point, let's say. Yeah. Okay, so let me draw the graph for the absolute value function. Right. So this is a sketch on the same diagram for the linear and the absolute value function. Now for part B, solve the equation. So as you can see from this sketch, there must be two solutions. This is a point of intersection and this is a point of intersection, right? So we can say that 3x minus 5, this would be x plus 2, or 3x minus 5, this would be equals to minus of x plus 2. I opened the absolute with the positive and the negative sign. Now 3x minus x would be 2 plus 5. And here 3x minus x would be, this minus becomes plus, right? Minus 2 plus 5, right? Now here we have 2x would be 7 and x is 7 by 2. And here 4x is equals to 5 take away 2 is 3 and x is 3 by 4. So these are the two solutions, 7 by 2 and 3 by 4. Question number 2, solve the equation. So secant is 1 over cos square theta, cot is cos theta over sin theta. This would be equals to 8. Theta lies between 0 to pi. So we can cancel one cos with this cos and we are left with 1 over cos theta sin theta. This would be equals to 8, right? So let me multiply and divide by 2, right? So from here we have 2 over, this is 2 sin theta cos theta sin 2 theta. This would be equals to 8, right? Now cross multiplication, 2 by 8 is equals to sin 2 theta and 2 by 8 is 1 by 4, right? And further simplification, we can say 2 theta, this would be sine inverse of 1 by 4, right? Now domain is in radians, the calculator is in radians. So sine inverse 1 by 4, this is 0.2526. 2 theta is 0.2527. And here sine is positive, so sine is positive in first and second quadrant, right? This is the value for first quadrant. Now for second quadrant, we can say 2 theta would be equals to pi minus theta, right? We can say pi minus 0.2527, which is 2.889. This is for second quadrant. Right. Now let me solve the values of theta by dividing by 2. So theta is equals to 0.2527 divides 2, which is 0.126, and 2.889 divides 2, which is 1.44. So these are the two solutions for theta, and this satisfies the domain between 0 to pi. Question number 3, the parametric equation of curves are x equals to this and y equals to this. Find the gradient of the curve at the point where t equals to 0. Gradient of the curve is dy over dx, right? So we have to use the chain rule, dy over dt times dt over dx, right, at t equals to 0. So first we have to differentiate dx with respect to dt and then put t equals to 0, right? So x is a function of t, so first we need to use the product rule here. So first function is as it is, the derivative of second function, the derivative of cos is minus sine 4t into 4, plus cos 4t stays the same. The derivative of e power 2t is 2 times e power 2t, right? Now when t is 0, we know that sine 0, sine 0 is 0, and what is cos 0 is 1. Okay, so when you put 0, this term would be 0, right? This term would be 1. Cos 0 is 1, so e power 0 is also 1, so we are just left with 2, right? So this would be equals to 2. Now dy over dt, differentiate the function y with respect to t and put t equals to 0, right? So we have 3's as it is. The derivative of sine is cos 2t times 2, right? So cos 0 is 1 and 2 times 3 is 6, right? Now let me substitute into the formula, the chain rule. So we can say dy over dx, this is equals to dy over dt, which is 6 times dt over dx 1 by 2. So 2 times 3 would be 6. This is equals to 3. The gradient of the curve at a point where t equals to 0 is 3. Question number 4. The diagram shows part of the curve with equation this. The shaded region is bounded by the curve, this curve, and the line x equals to 1 and x is equals to 3 and y equals to 0. Now part A, find dy by dx and hence find the x coordinate of the maximum point. Okay, so x coordinate of the maximum point. For maximum point we have to put the gradient of the curve equals to 0. So first let me find the gradient of the curve. Dy over dx, we have to use a quotient rule, denominator function square. Denominator function, the derivative of numerator function is 5 minus the numerator function. Derivative of denominator function is 3 times 4 is 12x square, right? Okay, now the next is you can say 5 into 4x cube plus 1 and minus 5 times 12, 60 x cube divides 4x cube plus 1 whole square, right? This is dy by dx. Now for maximum, we have to put this gradient equals to 0. So when the gradient is equals to 0, 4 times 5 is 20 x cube plus 5 minus 60 x cube, this would be equals to 0. The denominator function multiplied with 0 would be 0. So 20 minus 60 is 5 minus 40 x cube, this would be equals to 0. So we can say 5 is equals to 40 x cube, right? And 5 over 40, this is x cube. 5 by 40 is 1 over 8. 5 times 1 is 5, 5 times 8 is 40, and we can say x cube is equals to 1 over 2 cube. Now taking cube root on both sides here, x coordinate of the maximum point is 1 by 2, right? Now for part B, use the trapezium rule with 2 intervals n is equals to 2 to find an approximation to the area of the shaded region. Give your answer correct to 2 significant figures. Area of the shaded region, so this is the shaded region between 1 and 3, right? So the trapezium rule, the area formula is 1 by 2 b minus a over n. The function value at 1 plus 2 times the function value at 2 plus the function value at 3, because the domain is the range we have given, the bounded area is 1 to 3, right? Okay, so we can say 1 by 2, b is 3 minus 2 divides 2. Okay, f of 1 is, we can just substitute 1, 5 over 4 plus 1, which is 5. 5 over 5 is just 1. plus 2 times, we have to do 2. So here we can say 4 times 8 plus 1, and 5 times 2 is 10. So 33 over 10 out of 33. Yes, 10 over 33. And let me substitute 3 here. So we can say 4 times 3 cube plus 1, 109, and 5 times 3 is 15. 15 over 109. Yes. Plus 15 over 109. So this is 3 minus 2. Sorry, 3 minus 1. This is between 3 and 1. You can see. Okay, 3 minus 1 is 2, and 2 divides 2 is just 1. So this is 1 by 2. 1 plus 20 over 33 plus 15 over 109. Right, now let me simplify and find the answer up to two significant figures. 15 divides 109 plus 20 divides 33 plus 1 times 0.5. 0.8718, and up to two significant figures 0.87. This is the area. Now for part C, state with a reason whether your answer to part B is an overestimate or underestimate of the exact area of the shaded region. Right, as you can see, if I draw the trapezium, which mean these 2 points, right, let's say between 1 and 2 there is a point 2 over here. So we calculated there should be 2 intervals, 1 to 2 and 2 to 3. We just calculated the shaded one. So this is an overestimate because the top of both trapezium is above the curve end, which is not calculated. So let me write down the reason. The answer is overestimated why this is overestimated, because we calculated this whole area between the 2 intervals. We calculated this portion as well, but the question is just calculate the shaded one. That is why it is overestimated. So this is overestimated because the shaded area does not include the top of each trapezium above the curve. Above the curve. Because above the curve, the top portion of the trapezium, between the top of the trapezium and the portion above the curve, we calculated this one as well, but this one is not shaded. That is why the answer is overestimated, not underestimated. Question number 5, part A. Given that this expression equals to this, show that x would be equals to this. Okay, so first let me say ln of x plus 1 whole square plus ln x equals to ln of x plus 9. This is ln of x into x plus 1 whole square. This is equals to ln of x plus 9. Right, now let me cancel ln on both sides by taking exponential on both sides. So x into x plus 1 whole square, this would be equals to x plus 9. Right, now x into x square plus 2x plus 1 equals to x plus 9. Right, now x cube plus 2x square plus x minus x equals to 9. So plus x and minus x is cancelled. So x cube plus 2x square, this would be equals to 9, taking x square common, we are left with x plus 2. This would be equals to 9. So we can say x square would be equals to 9 over x plus 2. This match with our given one. Take square roots on both sides. So we have x would be equals to positive square root of 9 over x plus 2. Right. Part B, it is given that the equation x equals to square root of 9 over x plus 2 has a single root. Show by calculation this root lies between 1.5 and 2.0. If the root lies between 2 point, it means a sign change occur, right? So first let me calculate at x is equals to 1.5, right? So when x is 1.5, we have 1.5 here, right? And we can simplify 9 over 1.5 plus 2 square root, right? 1.5 plus 2, 9 divide answer, and the square root of answer is equals to 1.60. So this would be equals to 1.60. So here we can say 1.5 is less than 1.6, right? Now let me calculate at x is equals to 2.0, right? So when x is 2.0, we have 2.0. This would be equals to square root of 9 over 2 plus 2. Okay, so this would be 9 divides 4, and the square root of answer, this would be 1.5. Okay, now we can say 2.0 is greater than 1.5. So as you can see, the sign change occur. Sign change occur. This implies root lies between 1.5 and 2.0, right? Now for part C, use an iterative formula based on equation in part B to find the root correct to 3 significant figures. Give the result of each iteration to 5 significant figures. Make a formula xn plus 1 equals to square root of 9 over xn plus 2. And the root lies, we know that lies between 1.5 and 2.0. So we can say the initial guess is, let's say 1.75. You can take any value between 1.5 and 2.0, right? Now let's make a table of values. We have xn here and xn plus 1 here, right? So when x naught is 1.75, we have to find each iteration up to 5 significant figures, right? So we can say square root 9 divides 1.75 plus 2. 1.5491 up to 5 significant figures. Okay, 1.5491. This is 1.5924. 5924. This is 1.5828. Yes, 1.5828, which is 1.5849. 1.5849, 1.5845, right? And let's do one more iteration for 5. 1.5845 or 46, we can say, right? So here we have 1.5491, 1.5924, 1.5828, 1.5849, 1.5845, right, up to so on. Okay, so we have to find the root up to 3 significant figures. So here we can say the root is 1.58, and got the same 5 8 5 8 5 8 5 8, right? So 1.58 is a root which lies between 1.5 and 2.0 up to 3 significant figures. Question number 6. The polynomial p of x is defined by this, where a and b are constant. It is given that x plus 2 is the factor of p of x. It means p of minus 2, this would be equals to 0, and that the remainder is 5 when p of x is divided by x minus 3. So p of 3, this would be equals to 5. Find the values of a and b, right? So first we know that x plus 2 is a factor, so we can say p of minus 2, this would be equals to 0. Let me solve this. When x is minus 2, so minus 2 whole cube plus a times minus 2 plus b, this would be equals to 0. So this is 8 minus 2a plus b would be equals to 0. So minus 2a plus b, this minus 8, this would be equals to 8. Or from here we can say b is equals to 8 plus 2a. This is my first equation, right? Now let me use a second condition. When p of x is divided by x plus 3, the remainder is 5. P of 3 is 5, right? Now simplify the other side. Okay, so we can say 3 cube plus a times of 3 plus b, this is 5, so 3 cube is 27 plus 3a plus b equals to 5. So 3a plus b equals to 5 minus 27. So 5 take away 27 is 22, I guess. Minus 22. Yes. So 3a plus b, this would be equals to minus 22. This is my second equation, right? So let me substitute the b value into the second equation to get the a value. So we can say put equation 1 in equation 2, right? So we can say 3a plus 8 plus 2a, this is negative of 22. This is 5a would be minus 22 minus 8. So a would be equals to minus 22 minus 8 divided by 5. This is negative of 6. So we have the a value, which is negative 6. Now substitute the b value into equation 1. Put a in equation 1. So we will get b is equals to 8 plus 2 times of minus 6. So b is equals to 8 minus 2 times 6 is 12. So b, 8 take away 12 is negative 4. So b is negative 4 and the a value is 6. So we can say the polynomial p of x is x cube plus ax plus b, which is x cube minus 6x and minus 4, right? Now for part b, hence find the exact root of the equation p of e power 2y equals to 0. So first we have to put p of x, which is x cube minus 6x minus 4, right? We know that x plus 2 is the factor. So let me use a synthetic division here and find out the other two roots. Okay, right. So x cube coefficient is 1. There is no x square coefficient. X coefficient is minus 6. Constant term is minus 4. So we have minus 2. So bring 1 down. This is minus 2 times 1 is minus 2. This is minus 2. Minus 2 times 2 is minus 2 times 2 is 2 times 2, 4. This would be negative of 2, and 2 times 2 is again 4. This would be equals to 0, right? So we can write down as p of x, this is x minus 2, x plus 2, sorry, and x square minus 2x minus 2, right? Okay, let me solve this quadratic equation by using quadratic formula. So we can say that x would be equals to negative of b plus minus square root b square minus 4 times the a value times the c value divides 2 times of the a value, 2 times of 1, right? So here we can say x would be equals to 2 plus minus square root. We have 4 times 2 is 8 and plus 2 square is 4. So square root of 12. 2 square root of 3. 2 square root of 3 over 2, or here we can say 1 plus minus square root of 3, right? Okay, so let me find the 3 roots. So the 3 roots are x equals to minus 2, x is equals to 1 plus square root of 3, and x is equals to 1 minus square root of 3, right? So replacing x with e power 2y, right? Put x is equals to e power 2y. So we can say e power 2y, this would be equals to 2, right? So 2y would be equals to ln of 2, right? And taking ln on both sides, so y would be equals to 1 by 2 ln of 2, right? Now e power 2y, this is 1 plus square root of 3, so 2y equals to ln of 1 plus square root of 3, and y is equals to 1 by 2 ln of 1 plus square root of 3, right? And sorry, this is negative, sorry, negative 2, and a log of negative does not exist, this is undefined, right? Now moving to the third one, we can say e power 2y, this is 1 minus square root of 3, and y would be equals to 1 by 2 ln of 1 minus square root of 3. Let me check what is 1 minus square root of 3. 1 minus square root of 3, and it is negative again, so 1 by 2, and ln of answer is undefined, ln of negative, so we have undefined here, right? So there is only solution is only one solution. Only solution is y equals to 1 by 2 natural log of 1 plus square root of 3, right? Question number 7, part A. Express this in the form of r cos x minus alpha, where r is greater than 0 and alpha is between 0 to pi by 2, right? So we can say this is 5 square root of 3 cos x plus 5 sin x. This would be equals to r cos x minus alpha. Open the formula of cos x minus alpha. We have 5 square root of 3 cos x plus 5 sin x equals to r cos x cos alpha minus r sin x sin alpha. Not minus, this is plus. Yeah, for cos it's plus, and sin alpha, right? Now in the next step we have to compare the coefficients. Comparing coefficients. Okay, first let me compare the coefficient of cos x. Comparing the coefficients of cos x, we have 5 square root of 3 with cos x and equals to r cos alpha, right? Comparing coefficients of sin x, this gives me 5 equals to r sin alpha, right? Now we have two equations. This is my first equation and this is my second equation. Let me do squaring and adding two equations, right? So r square cos square alpha plus r square sin square alpha equals to 5 square is 25 times 3 plus 5 square is 25, right? So let me simplify. 25 times 3 plus 25, this is 100. So r square is equals to 100 and r is equals to 10, which is greater than 0. We have to take the positive of square root, not the negative one, because r is greater than 0. Now let me solve for alpha. To solve for alpha, we have to do r sine alpha, dividing the second equation to first, r cos alpha. This would be equals to 5 over 5 square root of 3. R is cancelled with R, 5 is cancelled with 5. So from here we can say tan alpha is 1 over square root of 3. Right. Now let me solve for alpha, which is tangent inverse of 1 over square root of 3, and it must lies in the first quadrant, right? Okay, so tangent inverse 1 divide square root of 3. We have pi by 6. So alpha is pi by 6, right? Okay, now for part B, as x varies, find the least possible value of this expression and determine the corresponding value of x, where x is between minus pi to plus pi. Okay, so from A part, we know that 5 square root of 3 cos x plus 5 sin x, this is equals to r cos x minus alpha, right? So 5 square root of 3 cos x plus 5 sin x, this would be equals to, okay, so we can say 4 plus r is 10 cos x minus pi by 6, this expression. We have given that as x varies, find the least possible value of this expression and determine the corresponding value of x, right? Okay, so we, for the least value, we can take this one. For least value, we have to take this cos. We know that cos theta lies between -1 to +1. Okay, now the least value of cos, this is the least value of cos, which is -1. We have to find the least possible value, right? Okay, we know that the least value of cos x is -1, right? And at x is equals to pi and minus pi, right? Cos pi is -1, cos minus pi is -1, because cos is the even function, so it absorbs the negative sign, and for negative pi it's again -1, right? Okay, so we have the given angle. In our case, we have given cos x minus pi by 6, right? So we have to find its least value, right? So when x is pi by pi and minus pi, so from here we can say x minus pi by 6, this would be equals to pi, and x minus pi by 6, this would be equals to minus pi. So what is x here? Pi plus pi by 6, which is 7 pi by 6, and this is x equals to minus pi plus pi by 6, which is 5 pi by 6, which belongs to the domain. The given range, we have minus pi to plus pi, right? So let me check. 7 by 6 is more and 5 by 6 is less. So 5 by 6 belongs to the given range. So we can say the least value, the corresponding value of x is 5 pi over 6, right? Now for part C, find the integral of this function. Okay, so we know that this function is 1 over 10 cos x minus pi by 6 and its whole square, and we have to do this with respect to dx, yes, not with d theta. Sorry, let me compare this with the given one. We have 5 square root of 3 cos x is replacing with 3 theta, 5 sine x is replacing with 3 theta and whole square. This is r cos x is replacing with 3 theta minus alpha and whole square, right? X is replacing with 3 theta. Yes, with respect to theta, we have 3 theta here and its whole square, right? Now let me simplify this further. We have 1 over 100. tan square is 100. Integration 1 by cos is secant. So we can say secant square of 3 theta minus pi by 6 d theta. Integration of secant square is cos. So we can say 1 over 100. Secant square integration is tangent. Tan of 3 theta minus pi by 6 multiply 1 over 3 theta, the derivative is 3, plus some constant of integration, right? So we can say 1 over 300 tangent of 3 theta minus pi by 6 plus c. This is the integration. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.